So today's talk is something a little bit different, and I was a little nervous in kind of presenting this, but I've been writing and teaching and doing PowerShell for almost 20 years. Really long time. And of course, in the beginning, focused like a lot of you, focus on syntax and mechanics and what code do I need to run or write to achieve a certain result. And it's all good. But I have now, over the last couple of years, have shifted my focus a bit, again, because I've been doing this for so long and seen so much out there from people like you, that I've started looking at what I call PowerShell squishy bits. The elements of PowerShell scripting that I see a lot of people don't think about, but I think they should, because they'll end up writing better code. Mechanics and syntax, believe it or not, is easy. You can learn that. You're learning that in other sessions here. You've got Copilot and Claude and all sorts of AI tools to help you figure out syntax and mechanics. What I want to talk about is, okay, so I got this code that will do something, but how can I make that the best code for a user to run? That user might be you, but it might not be. So that's kind of what I want to talk about here. So a few essential concepts to get going here as I figure out my notebook. PowerShell, when it is executed, doesn't exist in a vacuum. When you write a command, someone's going to run it, but it's going to be part of something bigger. It's very easy when you're writing that code to be thinking just on the code. People don't necessarily think about the context where that code might be running. AI tools are great for generating syntax and mechanics. They'll tell you, for the most part, what command to run, what the parameters should be, what syntax to use. Cool, I use them all the time. I usually have to correct it, but still, it saves me some time. But, as I'm saying, there's more to PowerShell than just mechanics and syntax. PowerShell is really about the people who are running it. So this is the thing that I think a lot of people don't think about or don't think about enough to write really good code, high quality code. Because I think, this little line here, that better PowerShell code is crafted. It's not generated. You can start with generated code, that's fine. But then you need to start thinking about your PowerShell projects as artisans. Really, if you want to generate high quality, really good code that's going to be used and you know is going to work, you need to do more than just accept the defaults that you get from AI. You need to craft your code. Now, I'm going to have to show you lots of examples. Don't focus on the specifics of my examples. A lot of them are arbitrarily and specifically short. So don't say, oh, yeah, well, I would do it this way. That's not the point. So focus on the concepts that I'm showing in my code, not on the code itself. So I'm going to break this down here into a couple levels. First, let's talk about command execution. So you're writing a code, someone is going to run it. What do you need to keep in mind? Get this to work. All right, so, and these are things I teach in my PowerShell classes all the time. Number one question, who is going to be running your code? Is it you? Is it someone from the help desk? Is it someone from HR that you have written a tool that you're delegating to them? What is their experience with PowerShell? Do you need to write a wrapper script that you can put in a batch file that they can double click on the desktop and have it run? Do not modify the system to double click and run a PowerShell script. Don't do that. Or do you need to create a GUI front end? But you can't make those decisions unless you know who is going to be using my code. What are their expectations? So if it's a help desk, and we'll get to some of this in a moment here, will they be running some other command like get AD user and want to pipe it to your command? And what are they going to do maybe with that output? We'll talk about output here a little bit. Maybe they're going to run some command, pipe it to your command, and then do something else with that output. But if you don't know what they might be doing, you won't know how to craft your code. Where are they executing it? Are they doing it in a scheduled job? Are they running it interactively? Do they, like I said, do they need a GUI front end that they can double click or something, a WPF front end that will surface up the code and the results? The bottom line that I think is you need to be thinking, how can I make that code as easy and as frictionless as possible for the user to run without having to work at it? And again, this could be you. And I want to make sure that that code will succeed. I'm an old school IT pro. I go back to the days of running DOS batch files on NT4 servers. And my fear at the time, and so this is like with big spinning metal disks. My concern, as weird as it is, was there'd be some stray neutrino that would come through and flip the bit in the script. And the script's going through and it's configuring the server, and all of a sudden, oh, I'm done, I broke. And I'm halfway finishing configuring the server and it's some crappy indeterminate state. When I run a PowerShell command, I want a high degree of probability that it will succeed. And we'll talk about some of those things. And that should be for you as well. Because certainly if you're writing code for other people to run, you don't want to have all those calls saying, oh, I ran your code and it didn't run. I got this error message, blah, blah, blah. You want to write your code, hand it off, and just know that it's going to work. So the things we can do. All right, so first off, don't force the user of your code to jump through hoops. Don't make them do your job. So here's an example. Again, it's just a very contrived, simple example, but it's the idea of don't make the user do the work, you do the work. So I have a simple function here called getDriveInfo, and it's, because it's using getSim instance, the drive letter for the filtering has to be something like C colon or D colon or whatever, okay? So in my notebook, I can actually run this. So it loaded the function. So the user may not know that, oh, I have to do C colon or D, I have to include the colon. They're just thinking, oh, I want to run getDriveInfo C, and then they get an error. Or they're overthinking it. They go, oh, I need to do C colon backslash. Again, an error. Because you're forcing the user to have to know, oh, no, you got to do it just like this. When what you really, you don't want them to have to know. So navigating the notebook is the biggest challenge right now. So the code, my little sample function just says processing and then whatever the drive is not doing anything. So I don't want to force the user to have to know to do that. So there are a couple ways we can get around that. Here is an expanded version of this. This also has some other features which we won't necessarily talk about. So now in this example, I'm trying to make it really simple. I'm just saying the drive letter can just be a letter. Because for a lot of people, we just think of C. We don't necessarily have to think of the colon. So in my code itself here, on line 9, I can take the input from the user and make the drive letter that I need for my filter. I'm not forcing the user to do it. I can do that. That's my job. I've also made it easy by using a validate pattern to verify that the drive letter they put in is valid, because it needs to be a drive letter of A through Z. Even though we normally don't use drives A and B anymore, but someone might. Otherwise, and then I have some error handling. So now the user, let me get this to run. Load the function. And now they can just run drive C, and internally I've done the work that I need to do. I'm not making the user jump through hoops. Now I can take this a step further, and we'll talk about this a little bit later. Here is a version that's using an argument completer. And in this argument completer, I'm basically getting all the Win32 logical disks and getting the drive letter. So making it even easier for the user. If I load this, well, actually here I can do, because I have this loaded here, get drive info. So now I'm just hitting tab, and it's cycling through the argument completer. So now it's also, in this example, in this version of the function, it's also, I've changed the filter and the drive letter and the parameter to go back and using the colon, but I have added features to take away the user having to remember to put in the colon. So that argument completer does two things. One, it makes it brain dead simple for the user to pass a value, and it's kind of getting validated at the same time. Oh yeah, demo in the live console. All right, so the big thing about writing code, functions specifically that someone needs to input parameters. Number one, don't assume that the user will enter parameters in the same way that you do. You write your function, go, oh yeah, I know what I'm doing, and get foo, dash name, dash size, whatever. You have no idea how someone is going to use your code. You have no way of knowing where they're getting parameter values. They could be writing some other command. They could be expecting pipeline input. That's why we have stuff like parameter validation. Because I have no idea how someone's going to populate the name, the computer name parameter. Maybe they're reading a CSV file. Maybe they're reading a text list. Maybe they're typing in manually and they fat finger it. Or something else. You have no way of knowing. So you have to take that into account. So here is an example. I got this little simple test function called save data. And this is saving data. So the path here is a string. And I have parameter validation. I've got two validation tests actually. One, to make sure that whatever gets passed in is not null or empty. Because maybe they are reading a variable, but that variable was set somewhere and it's null. In which case I want to show one type of error. Or I can also validate the path. So I'm using validate script. And this code that I'm using here would be PowerShell 7 because I have the error message. That's another thing to think about. If you are going to have an error, you don't have to rely on PowerShell's sometimes obtuse messaging. Take the time, write a custom error message that makes it meaningful to the user. Oh, I can't find the path. And if you use a little placeholder, the 0 there in the curly braces, the value that they pass in the parameter goes into that spot. So if I am with the user and I make a mistake and put in an invalid path, I'll see an error message saying the path, whatever I typed, does not exist, or whatever you want. And then you can see the other types are like credential and whatnot. So let me load this. So here's some examples of using. So my scripts directory, the scripts data directory, so I can get this to come down so you can see the output. The directory exists, but there's no files in it. So my hypothetical function here is expecting to take files from a path and save them, do something with it. Okay. So that's this first line here. Probably should split this up into separate cells. The second line, $P, you can see that I'm getting no results there. So if I try to run save data on $P, that's where I get my argument is null or empty, because $P doesn't have a value. Now it would be nice, I don't think there's a way with validate null or empty to come up with a custom error message. I could do my own validate script and test for null and then write a custom message. That would be another possibility. Let's see here. So the question is, could you have multiple validate script on the same parameter? You could. I would probably try to not do that if I could. Because then your error message, you have to be able, so if you have multiple script validations, you could have unique error messages for each. But yeah, you could. Yeah, that's a lot. Oh, and here, so now if I try to run this to a totally non-existent directory, there you can see my custom error message. But this also, with the validation, that also ensures that the command is not going to run unless I have everything I need to make sure it's going to run. Again, I don't want to be halfway through and realize, oh, I'm missing something or some value is invalid and it pukes halfway through. I don't want that. When someone runs a command, I want to know with a high degree of probability that it will succeed. And it's not going to take the user a lot of effort to do that. Now, you do have to, you don't know or can't anticipate every use case, but you do have to try to think of some of them. You have to have some idea about a likely usage scenario. I mean, if you're writing the code, you probably have that in mind already, because you're writing the code to fit some need, thinking, yeah, I'm going to do this thing, and then I'm going to send it to my command, and then do something else with it. So you're kind of building with a scenario already. This comes back to thinking about who's going to run the code, and why do they need to run the code, and what are the commands that they might want to run with your code. You always want to be thinking, how can I make my code easier to use? So this is where we start thinking about things like aliases. And by aliases, I mean command aliases, because there's nothing wrong with making it easy for the user to type an alias to run your command interactively. That's perfectly fine. Parameter aliases, whether the command's going to take pipeline input, things like parameter sets, all these things can make your code easier to use. So let me give you an AD example here. So I have this function. I can run it because it's not really doing anything. So the idea is I'm going to get something from AD, get a computer name, and back up something with it. So I can do backup AD computer, name of a computer. You can see that it works. All my function does is just display that with right host. But I'm going to expect that the user will want to run a command like get AD computer, some sort of filter, and pipe it to my command. Well, that is going to fail with the way my command is written. And if I may not be able to see that, but the error here is cannot bind argument to parameter computer name because it is an empty string. And for those of you who are not familiar with Active Directory, this is what you would do to troubleshoot this. So I do get AD computer, SRV1, and look at all the properties. There is no property called computer name. So when I pipe my object to my command, it's looking for computer name, doesn't exist, error. Now, normally, this would be easy to fix. In my function, I would create an alias that matches the property name of the incoming object. So I know that the AD object has a name parameter, or I'm sorry, name property. So I could make computer name and give it an alias of name. If this wasn't AD, I'd be good. But as some of my friends in the room know, the AD commandlets are weird. And they don't quite work the way that we expect them to. So I've got this version, and this has my alias. Now this will kind of look like it's working. So I'm doing get AD computer, filtering for SRV, whatever, piping it to my command, and I can see that it's backing it up. This will also work with CSV files, for example, because I'm giving it an alias. So let's say my help desk is they've got a CSV file that's generated by some other department that they use to populate, to do stuff. But the CSV file doesn't have a computer name parameter or heading. It's got name. So if I make my alias match the incoming data, I have simplified things. Otherwise, they have to jump through hoops. They have to import CSV for each object and then pass the right name. They got to know what the right name is, or they have to pipe it, select object, do a custom rename. That's way too much work. It takes too much time. So if I have, here's my sample CSV, see, computer name will work, and if it was name, it would also work because I have the alias. Now, another way that I could do this, and unfortunately, because I'm running an ARM-based laptop, I don't have a working Active Directory that I can actually demonstrate in, so I just have basically screenshots of what I did on my desktop at home. You may want, again, thinking about who's going to use this, how they're going to use it, to create a parameter set. So same command, but I've got two parameter sets. They may specify an object by name, and I can have computer name as the parameter, but given aliases of like name. CN is a common alias that you'll see often. Or, so that use case would handle things like importing a CSV. The Active Directory stuff, which isn't clear in my examples, doesn't work right because of the way AD writes objects to the pipeline. However, if I know that the incoming object is a Microsoft Active Directory Management AD computer, then I can treat that basically as an input object. And that's why that is in a separate parameter set. Then in my code, down here in the process block, I just have some logic using PS commandlet. So if the parameter set is by AD computer, all I have to do is just set the computer name parameter to the name property of the incoming AD computer object, and that will work. So I've given the user some flexibility. They can either import CSV, they can type it by names, they can read in the text file, or they can pipe output from get AD computer. Any questions so far in that? So that's the syntax that the user would see. So I've got two ways of using it. And PowerShell is smart enough. So here is some verbose output of what it would look like. Or by using names, by importing the CSV. So that's all kind of what I have thinking about input to the command. So now let's talk about command execution. You want to give the user meaningful feedback when the code is running, especially if code is running a long time. Now, I should mention it here, I didn't. You should learn how to use write progress. Don't use write host to give the user feedback about something that's running a really long time. Learn to use write progress. I also encourage people to use write verbose, primarily write verbose, and possibly some write debug messages. And put this in your code from the very beginning. I have also started using write information a lot more lately. How many of you use write information in your functions? Okay, smart people are doing that. Well, I think it's because a lot of people don't know the value, and I'm going to demo that here. So let me give you an example. I have a module I wrote. It's up in the PowerShell gallery called a PS Blue Sky. So it uses the Blue Sky APIs and allows me to manage Blue Sky and Skeet and everything right from PowerShell. So I just created a Blue Sky session. Now in my command to get me my profile, I'm going to use my verbose output. Let me scroll this up here. So you can kind of see there, my verbose output gives me meaningful information. It's got a timestamp. I know how long it's going to take. I'm fond of putting in a prefix that shows me if I'm in the begin, process, or end script block. Again, so I can, if I'm having trouble, I can kind of follow through where I'm at. You can see the first line, starting the name of the command. At the end there, it'll say ending the command. Because I often, in my module, will have one command that calls another command. And so by having that verbose output, I can see, oh, I'm in this command, doing. Oh, I'm going to this command. Okay, that finished, and I'm back over here. There's no limit to what you can put in your verbose messaging. You can see I'm also capturing PowerShell version, the PowerShell host, the operating system, and then the other messages are actually in the code itself. Now, the reason that I like this, and the reason I think you should like this, go back to my idea that you have to support your code. So you create a function, you give it to her to run, and she yells at you because this is the crappiest code she's ever seen because it doesn't work. Yeah. So you say, okay, that's fine. Take a breath. Run the command, or start transcript. Run the command exactly the way you were doing it, except add -verbose. Error, whatever. Stop transcript. Send me the transcript. I can then, or you then, can look at the verbose output and see exactly how the code is progressing. In my case, with this code, I can also see what the environment is. So maybe you say, oh, well, she's running it in some other version of PowerShell that I know is not supported. That's a problem. I need a test for that. So, but the verbose output can help you as much as the user. So I'm happy to say I rarely have to use the traditional debugger in VS Code because when I'm writing and developing my code, I'm putting in verbose messaging from the very beginning. So when I run it with verbose, I can see where I'm at, the state of variables. I can see the flow. And in the Blue Sky module, I'm actually using a custom verbose command that writes the verbose messages, but you can see I'm using PS style to italicize the messages and create hyperlinks. And then there's the end. So the code, let's see if this will work here. I should have loaded this up earlier. I mean, the code's up on GitHub, but you'll see in the code, I'm not going to wait for this to, oh, there it is. So the underscore verbose is my private verbose message function. And in this case, I'm also using this module, localized string data, so that if I want to change that starting message, I just have to change it in the localized string data and not across 20 functions. So here's the other thing. We'll talk about write information since it's right here. So write information is really handy, especially if you are writing code that is like pulling stuff here, in this case from an API. So what I'm doing here is I am using write information, and I'm saving this variable from inside my script to the information stream. And I can actually tag it. Usually for this stuff, I give it a tag of raw. I'm getting the message header that comes back, writing that to the information stream. The reason I want to do that is for this. Now let's go over here and do it. And start. Now I already have a default, my little loading script also defines a PS default parameter value so that all of my Blue Sky functions automatically turn on information action, or information variable, and automatically save them to a variable, but I'll do it the normal way. So information variable, we'll call it X. All right, so there's my function that runs. Now $X is a list of all the other kind of objects that was generated internally in my code, and I can now surface them. So like the first one, $X0, and this is stored as message data for those of you new to this. So that is the session variable. So if I wanted to troubleshoot, I think the last item here, oh, that's the header. Oh, I didn't do -1, sorry. Yeah, so this is the actual data I got back from invoke REST method. So I don't have to try to capture it while I'm running. I can run my code, look at the information stream, and then go back and, as a developer, look at the objects that I'm working with inside my code. Or this, again, can be a troubleshooting thing for the user. Because this is now, if I wanted to, right, this is just another object. You can say, yeah, convert to JSON, save it to a file, send me the file, or whatever you want to do. So the information stream can be very valuable to you. All right, how are we doing time? All right, let's jump here to output and objects. Again, just like you have no way of knowing how someone's going to run your code, you have no way of knowing how someone is going to consume the output of your code. I'm assuming you're writing a function that's going to write some type of object to the pipeline. But again, you have to kind of think about likely scenarios. Are they just going to view it on the screen? Are they going to pipe it to another command? If they are going to pipe it to another command, what can you do to streamline or make that as efficient as possible? How can you take advantage of parameter binding in the pipeline from your object to the next command? Which might mean you need to define your object. Maybe a property name needs to have something that matches the likely target command they're going to pipe it to. Or you could do this. You could stick with your original property name, but as long as you have a custom object with a unique type name, you can extend that type and define an alias on your own custom object. So now your object output has the appropriate property name, but it also has a friendly alias that can be consumed downstream. You should also, when you're writing objects for the output, don't worry or don't focus on what it's going to look like, or if it's too many properties, or if it's too overwhelming. You should write the richest object possible to the pipeline, anticipating anything that the user, again, could be you, might want from that output. Formatting that output is a separate step. Formatting doesn't go in your function. That's where we create custom formatting files. Write the object that's rich. Here, let me give you an example here before I run out of time. So here is a function, resolve who is, that goes out to Aaron.net. And I'm just writing an object that's just returning the IP, the name, the registered organization. However, I'm leaving some valuable information or potentially useful information on the table. So here is a revised version. And so look at this object. So now I'm giving it a unique type name, who is result, and look at all the other properties. Yes, the user may not want to see them 95% of the time. I can create a custom formatting file that when they run the command, they'll get the results that I think they likely want to see. Microsoft did that for you for get process and get service. You can do the same thing. Someone at Microsoft decided when an admin runs get process, they likely want to see this output formatted like this. But you all know that if I do get process pipe to select star, there's a lot more there. If you need it, you should be doing and thinking the same thing. Don't try to limit yourself. Don't try to cut corners. Make it valuable to the user. So my kernel is crashing. This changes the color, but you can see I've got more properties here. So I do have, real quickly here, here's a complete working example. So this function, I'm not going to quite run it. We'll go through and get a directory listing and then build an object that will show me, because I can run it, file extension information. And that code is being generated in the process block. You see I'm using a bunch of select object statements with creating custom properties. Now, that kind of works. I get the output I want. I'm formatting as a table. You should never have formatting command lists inside your function. That's a big no-no. But I want to try to make this more human-centered. I want to add some value to this. So here's some things that I've done in this version. Let me run it, and then we can go back and talk about it. So this version, if you look through, has lots of write information messages, has lots of verbose messages. My output now is a richer object, and I've added things like additional properties, like a percent total, because I'm assuming the person running this might want to know, hey, given these files of PowerShell files in this directory, what percentage of that? So I don't have to make the user do that. I can give them that information. Add stuff like the computer name, because someone may run this code and then serialize it. And then I look at that later and go, well, that's nice, but what computer was this on? So I almost always like to include the computer name. Same thing like I have a property there for the report date. When was this generated? So if I'm looking at this data later, I have some context. I also have a property for is largest. And that is in there because I have a custom formatting file, which I won't get into, but here I can run this. So there's my verbose output. I can look at the properties. I can use update type data and add an alias property for instead of forcing the user to know total size is the value you want, because they may just be thinking, oh, I just want the total. So I'll give them an alias to make it easy. And I create a custom formatting file. So this, I think, I'll just do it in the... So my custom formatting file says, hey, if this object has the is largest flag set, then display it in the color. So I've added some extra value to the user. They can look at it and go, oh, well, that's helpful to know. They don't have to do a quick sort, or it just jumped out at them. I'm a big fan of using PS style in my formatting to add additional information. So let me quickly jump down. Things like property sets, additional formatted views. Let's here go down to the TLDR. You need to consider when you are crafting your code, and I hope you start thinking of your code that way, consider who's going to be using your code. How will they be using it? How might they want to use it in the future? You don't want to have to go back and constantly update your code. That's why I say write the richest object you can from the very beginning. Don't assume. You still have to have some idea, but don't assume that you know how the user is going to use your code, consume the output. They're not going to use the code the way that you use the code. I used to work for a consulting firm, and we had a developer team, and the developers we had a customer, and he would say, okay, show me the latest build of the code. And his test was keyboard smash. And so they had to learn, the developers had to learn, okay, we need to code and take that into account. We would never think that that's what someone's going to do, but they had to code for that. Because it would fail, go, yep, you're not good enough, go back, fix it. Create rich objects and write tools, again, that are elegant, effortless, efficient for the user to run. Design your tools. Don't just generate code. Generating code is a good start, but don't assume that once ChatGPT gives you code that you're done. There's so much more that I think people need to think about. And again, I think of it as the squishy bits, because there's nothing necessarily technical about what I showed you. I kind of showed you why some things like parameter validation exists and why you should be using it. So any questions while we're at the end of time here? Yeah. So the question is basically, when do I use write verbose and write information? You can do both. Verbose messaging is information that the user can see to let them know this is what's going on. Right information, I use more, and I think more of additional information that I can look at after the fact. Because I don't see, unless you can turn on right information, there's an information action. And if you set that to continue, then all of those right information things, but I use right information to actually write actual objects. And so I'm saving those objects so that I can then look at later. Exactly, yeah. So the right information, a lot of right information was written, I think originally designed to just write another message, a string, but you can write objects. Now, sometimes you then have, I've been doing some other stuff with right information, and I have found I can't write the object. I actually have to take the object, convert to JSON, and then I write that converted JSON to the information stream, and then I consume it later. So you have to sometimes. So yeah, I use the information stream for additional information, because the other thing about crafting your code is crafting it for you or someone else to maintain. And so if you give them the tools to help them troubleshoot what's going on, and right information is a good way for that. That's why we have best practices, formatting, and all of that.
And to be clear, none of this kills puppies.
No, I've not killed or hurt a single puppy.
Thank you.
Anything else? All right, I don't have the slide that reminds you, but fill out the eval apparently, and thank you all for coming. Enjoy the rest of your time.